Our last video explored three foundational types of interaction: selection, exploration, and abstraction. And while these common foundations form many of the interactions that you'll see in modern visualizations, it turns out we can also get a little bit more sophisticated. In this video, we're going to explore how interaction can let us look at visualizations from different perspectives, changing the ways that we represent data, and also how it can help us understand connections across perspectives, how it might support us in sense making when we're looking at multiple charts at once. So today we're going to talk about four different categories of interaction. These are going to be the remaining four in our common forms of interaction, and they are reconfigure, or show us the same data in a different order; filter, which is focusing on a specific subset of data; encoding, which is taking the same data and showing it in a different way; and connection, which is showing common objects or common data points that occur across multiple charts. As a reminder, for each of these types of interactions, we have a complementary hands-on activity where you get to implement that interaction in Altair in the accompanying Altair notebook. You are welcome to either pause the video after each type of interaction is discussed and try it out right away, or you can wait till the end of the video and revisit these different techniques as part of your general review of interaction. So to start, when we're talking about this idea of reconfiguration, the basic idea here is that we're just changing the way we're sorting our data. Sorting is critical for a number of reasons. Most importantly, and I think most commonly, it's often used to bring important data to the top. If we put information at the top or at the left of a chart, people tend to see that data first, just based on the way that we read. We tend to, in English-speaking cultures, read left to right, top to bottom. So putting data in that spot means that people are likely to see it. Sorting can also highlight clusters or groups that form within the data and help us discover patterns across different attributes that we use to order our data. We can also organize data according to different units, making it easier to find particular relationships or allowing us to emphasize those relationships that matter the most in our data. When we talk about sorting, there are two common forms of sorting that we'll see in visualization. The first is just simple reordering, where we're organizing our data according to some dimension of the data. And the second of these is what we call seriation. So we use seriation when we are ordering our data according to some computed metric that's intended to help us see specific patterns in the data. So let's take this bar chart as our preliminary example. So here I have two different ways of reordering or sorting my data. For example, I can start with the bar chart over here on the left, where what I've done is I've just essentially shown the data in terms of the highest overall value within each of these regions. And I can change the way that I'm ordering these countries to, for example, sort the countries alphabetically. If I sort them alphabetically, it's going to be much easier for people to find data about a specific country, but two countries being close together may not actually tell me anything meaningful about my data. On the other hand, I could choose to sort and reorder according to specific metrics. So for example, I might choose to order my data according to the overall average value. So here I get this nice ascending slope where I can see very quickly where are the countries that have the highest overall values and where are the countries that have the lowest overall values. Or pardon me, regions, not countries. So another thing that I can do once I've found data that I'm interested in is I can actually choose to explicitly filter. We've talked a little bit about filtering as a way to indicate selection, but filtering actually turns out to be a very rich suite of interactions in and of itself. When we're dealing with filtering, we are essentially just choosing what subset of the data do we want to work with. So one thing I can do to filter my data is I can use something like direct manipulation. The basic idea behind direct manipulation is that I choose the data that I'm interested in directly from the visualization. So we see this implemented as things like hovering or mouse overs or clicking on data points or doing lasso selections to select data in a region. And we can see a little bit of that here, where as we mouse over different regions of the world, we can see that we're explicitly showing the values for those of those countries that match the region that I've hovered over, that I've filtered for. The complement of direct manipulation is a context called dynamic queries. So the idea behind dynamic queries is that we want to choose our data using queries, and these queries are usually driven by widgets. So you can think of these as things like search boxes or sliders. These are complementary widgets where we can choose a specific kind of query that we want to run based on the actual values of the data. So in this video here, what we have is we have just a drop down that allows us to select different regions of the world based on those region names. And as we select those regions, rather than having to hover over, mouse over, we can select things that way. So when we're trying to reason over what should we use, direct manipulation or dynamic query, in part we're going to think about what is the specificity of the data that we want to work with. With direct manipulation, you're doing that selection directly in the context of the visualization. So you can actually choose and filter data based on particular relationships between those attributes. For example, I could choose a region of this scatter plot that offers an interesting combination of happiness score and health or life expectancy. And I could find, for example, clusters of patterns that emerge on the fly to find data points I might be interested in. On the other hand, with dynamic queries, what I'm doing is I'm choosing based on very specific parameters of the data. So if I know the exact parameters and properties of the data that I want to filter for, dynamic queries are a great way of doing that quickly and efficiently. But it's much harder to choose the data we're interested in based on emergent properties of the data, like relationships between different dimensions. Another kind of interaction that we'll often see in visualizations, and this is something that's especially common in business intelligence tools and exploratory analytics tools, are encode interactions. So with encode interactions, what we're trying to do is we're trying to see the same ideas, the same data, the same patterns, but we're seeing it in a different way. We're choosing different representations that might allow us to build more rich insight into our data. Two ways that we often will do this kind of encode interaction are changing our mapping or creating multiple visualizations at once. So think about this as building or layering visualizations through dashboards. So if I'm going to encode my data and I want to change my mapping, I can either change the data itself or the visual channel that the data maps to. So for example, I might choose to map one dimension like generosity from color and move it over to size to see different kinds of patterns that might emerge. For example, here, I might also change based on my dimensions, I might go from setting size to map to freedom to setting size to map to generosity. And by changing the secondary dimension, I'm getting a little bit different perspective on what is going on overall in my data. Another thing I might do is I might use multiple visualizations at once, and I might composite these visualizations together. For example, I might take my scatter plot here on the left where I have my relationship between happiness score, health, and then generosity as size, and I might put next to it my visualization where I have happiness, health, and freedom as size. So this is really commonly done in things like dashboards, where we can move around and update the visualizations that are being shown in a dashboard and change the arrangement of those visualizations to try to make different relationships easier to see. But it's coordinating these visualizations that introduces its own interesting set of interaction challenges. And we're going to oftentimes address these interaction challenges through connection. So essentially what we're trying to do is we're trying to highlight different common relationships that emerge across different perspectives on the same data. The core idea that lies at the heart of many different connection interactions is the idea of multiple view coordination. So when we're dealing with multiple view coordination, the basic idea is that I have different views, different visualizations, different perspectives on my data. And by interacting with one perspective, it tells me something about the data I'm looking at in another. So for example, here I have my bubble chart with health and life expectancy and happiness score, and then I have a histogram that looks at the overall distribution of happiness scores. And what I can do is I can use multiple view coordination to try to find relationships that might emerge across these two different visualizations. So two common methods for doing this are what are called brushing and linking. When I'm brushing, what I'm doing is I'm selecting a subset of data and I'm applying an interaction effect to other data in that data set. So think of this as I select a set of points in my scatter plot and I highlight or lowlight those corresponding bins in my histogram. When I have linking, I'm getting a little more sophisticated. The action that I'm taking in one of my visualization results in a corresponding action in another. So if I select a subset of data points, maybe my histogram updates to show me information only pertaining to that subset of data points that I've selected. So I can see a little bit of this here, where I use a lasso selection, and based on my lasso selection, I see these blue bars drawn that illustrate the distribution of happiness scores that are within that selected region where I've applied my lasso. So there are a wealth of other interesting visualization techniques that exist out there. Many of them will composite many of the ideas that we've seen here. And quite frankly, there's still innovation going on in terms of what are alternative ways that we might choose to interact with our data. Things ranging from physical interactions to input sensors and devices to even exploring how do we talk to our data? How do we use natural language to try to select interesting information? And so I'd encourage you to keep looking and keep playing and keep experimenting in this space. As I mentioned, there is an Altair notebook, which I would encourage you to take a peek at, where you can start experimenting with all the different interactions you saw in the videos here. But there's a wealth of information and implementations available more broadly as well, if interaction is something that you see as being useful for your own visualization work. That's a wrap for our module on interaction, and I look forward to seeing you all in the next module.